So 8.3 is about absolute value function.
Absolute value.
Okay, so the idea, just to review, of a function is this thing with blobs, right?
Mm-hmm.
Yeah? Blobs? What do the blobs represent?
Inputs and outputs.
Okay, so these are kind of inputs, outputs. What do we call these?
Domain and range.
Yeah, so the whole blob is called the domain, right?
X's and Y's.
And the set of outputs is called the range.
Range.
And then we usually give this thing a name, right? So normally I'd say something like x goes to f of x, right? Do you guys know a name for the absolute value function or a symbol for it?
Oh.
Yeah, these things. The little dot in there just means fill in the spot, right? So when I'm filling in this spot, I'm going x goes to absolute value x. What's the rule for that?
There's two answers.
So what do I think about this thing? Absolute value of x is the
Furthest distance, or the distance from 0.
yeah, is the distance, right? This is a positive number at distance. That x is from
Zippo.
0. Good. Cool. So this just tells us what the absolute value function does, right? See that? Takes a number,
I wasn't looking.
X.
He was-
when I put these symbols around it, it tells me how far x is from 0. We pull that? All right. So that's really all there is here. But we can put this together with some of our 12.3 stuff and learn to draw some kind of complicated absolute value functions. So we should probably learn to draw this one first. Did we do that one yet?
Kind of. In 12.
Show of hands for people who think we've known what this looks like. So show of hands for people who don't remember that graph. Okay, some of you? All right. So let's do graph absolute value of x. So how do I start graphing a function I don't know about?
Get some points.
Yeah, let's get some points. So let's make a table. X's and what?
F
Of
of
X.
X.
F's of X.
F of X.
F of x's?
Absolute value x.
Absolute value of x, right? That's the name of this function.
The name of the game.
You guys see that?
Yeah.
This function has a different name. What are my 5 favorite points? Have those changed?
0, 1,
0, 1,
Negative 1.
negative 1.
negative 1,
Negative 2.
negative 2.
8.
No.
Okay, we'll put stories 8 down there. All right. What's the absolute value of 0?
0.
How do you know that?
0 is 0 away from 0.
Yeah, 0 is 0 away from 0 is the phrase you want. How far is 1 away from 0?
1.
1. How far is negative 1 away from 0?
1.
1.
2.
2. 2. And 8. Wow.
8.
7.
Upright infinity.
Okay. Okay, so if I thought about, if I put any positive number in this thing, what's the output?
Positive. Same number.
Positive, the same number, right?
Mm-hmm.
What about if I put a negative number in it?
Positive that number. Positive.
You kind of think to yourself, positive that number, right? But that number was negative. How do you make a negative number positive? Times it by another negative. Which one doesn't change how far it is from 0?
It's identitive property.
Close.
Negative 1.
Yeah, multiply by negative 1. You guys see that? So another way I could phrase the absolute value function, this thing, is I could say, this is just the same thing, right? If x is bigger than or equal to 0. You guys see that?
Greater than or equal to 0.
Right? It doesn't do anything to positive numbers. And what does it do to negative numbers? Makes them positive by just slapping a minus sign on them. You guys see that? So this is another way I could think about this thing, is by these two pieces, right? It either gives you back what you gave it, if what you gave it was positive, or it slaps a minus sign on it if what you gave it was negative. Cool? That actually gives us a nice convenient way to graph. Or we could draw points. So what's a convenient point on here?
0, 0.
0, 0 is really convenient. What's another convenient point?
1, 1.
1, 1.
Negative 1, negative 1.
Negative 1, 1.
And then just V out forever.
You guys see that? Why is this a V and not a curvy thing?
Because we drew it that way.
The numbers are essentially the same.
Yeah, the numbers are the same roughly, right? You guys see that? If I go one more unit away from 0, right? It doesn't matter how far away I was to start with. My distance from 0 increases by 1 unit, right? So that's this thing. So there's your two lines. Notice this thing is half of the line y equals x, right? You guys see that? Y equals x would go like this, and then when it got here, it would continue down here, right? This is half of the line y is minus x, right? You guys see that? That's really this piece. So here's our graph for absolute value of x. Cool? Note, this is in fact pointy.
Called a vertex.
Yeah, it's got a vertex, right? The vertex is pointy in this case. Parabolas also have vertices, right? Where's a vertex of a parabola?
The tippy bit.
Yeah, the little roundy bottom or top,
Or nippies.
depending on whether it's pointed up or down, right? So this thing has this pointy bit, which is actually kind of important. This is one of the few examples of a function we kind of start with that has a pointy bit on it. Most of them are nice and smooth. Cool? All right. So there's our graph. What if we wanted to do something like graph f of x is negative x plus 2 plus 3.
We can do that.
We should be able to do this using our chapter 12 stuff, right? Okay, so see this thing and you think up 3, right?
Yep.
How about this plus 2 business? What do you think about that?
Shifted left.
Left by
2.
2.
good. And what about this minus sign?
Flip it upside down.
That's flip. How do you know it's upside down and not this way?
Because it's,
You guys see that? There's this flip available and this flip.
before the rule. After. After.
Is it before or after the rule?
After, because they have the combining rule. So.
It's after. I do the absolute value first, right?
Oh.
You guys see that? So this is an after the rule flip, which means it's a vertical thing, right? It's flipping the outputs, the y's. So there's a vertical flip. So what am I looking at? I should be looking at, go back 2, up 3, and then what? Yeah, upside down V, right?
Yeah.
You guys see that? So when I go over 1, I should go down 1. And when I go back 1, I should go
Yeah.
down 1. And now there's my V shape.
Yay.
You guys see that? This is F. Cool. We can do a little better job labeling our picture, right? So if we were going to do a nice job, we'd do x's, y's, 1, 2, 3, negative 1, negative 2, negative 3. Cool. Questions on this?
The vertex on the graph, is that the same as negative b over 2a?
So for a parabola it is. It's at the x value, negative b over 2a. On this thing, I don't have a b or a 2a. That makes sense. I don't know what a, b, and c are in this context.
I just recognize the same term, so I was just trying to find out.
Yeah. Yeah, so for a parabola, this guy is the vertex. That happens at negative b over 2a, comma, whatever the output for negative b over 2a is.
Oh, okay.
You guys remember that thing about parabolas? They have them. Welcome to 8.4. You can forget this until 8.4, and then we're going to talk about it a little bit. Cool? But the other vertex does happen. It's on a parabola. It's also an option. It has this special, this one's curvy, this one's pointy kind of thing that you should notice. Cool? This is the only pointy basic function. That might be worth noting for some reason. Like when we get to calculus, pointy things will be terrifying.